Alright, so this is part 2 of the complex conjugate problem that we were doing before. And my camera seems to not want to focus, it looks like, for some reason there. It's still kind of blurry. There we go. Alright, back into focus now. So, the next thing that we do is basically multiply this out. So, we got 5x cubed or 5x squared here. Our next thing is to do this. These three. Alright, did anybody not understand what I did here? All I did was take all of these right here, all the x's, and went on ahead and, the x, and put it to all three of these terms in this other binomial. Alright, that's all I did. So I'm going to continue on from here. Alright, so now, plus 5x squared minus x cubed, then
plus 4x.
Plus 4x, good. What's next?
Minus 5x.
Minus 5x. Alright, now I take, excuse me, the last three and go here, here, and here. Oops, there. Alright. So now I got all my different color codes going on. So what's the next thing, sir?
Minus x cubed. Or
wait a minute, hold on. Did I draw it to the same?
Yeah, you did.
Apologize, world. I apologize. I must be getting thrown off now that I did like all these sessions back to back today. Okay. I messed up my whole pattern and everything. Okay. Alright, sorry about that, guys. 12. There we go. Well, what are we saying now? What do we do now?
Minus 12x squared.
Minus 12x squared.
Plus 48x.
Plus 48x.
Minus 60.
Minus 60. Outstanding. Good job, sir. Now, I do what now? I do what we call a CLT. Combine like terms, right? So, when I do that, x to the fourth is a loner. He stays by himself. The cubes come out. The 2's come out. All the x's, they come out, and otherwise the number by itself is a loner too. So x to the fourth, when I simplify, what I get, sir, on the cubes?
Minus 5x cubed.
Cube minus 5x cubed. What else? What's the square part look like?
Minus 3x cubed.
Huh? Squares.
Oh yeah. Minus 3x squared.
No. 5x squared minus 12x squared.
And what about the 4x squared?
Huh?
The 4x.
Did I miss it?
Yeah.
Where is he at?
It's right there. Or
yeah,
I thought
here? Yeah. So wait a minute, hold on.
You just didn't put squared on it.
Oh, I just didn't put squared on it?
Yeah.
Like that? Okay, alright, my bad. Thank you. So it's 5 plus 4 is 9 minus 12 is 3, right? So minus 3x. Alright, good job on catching that. That's good. Thank you, sir. Appreciate that. Now what? What else I did? What about the ones? The onesies?
It's gonna be plus 43x.
These, right? Okay, good. So plus 43x minus
60.
And this, guys, is my answer. Oh my gosh. It is long, but once you get it done, though, it's almost like a self-fulfillment. You know what I'm saying? Like you accomplished something. You know what I mean? Like you just really did something really good with all of that work up there. It's a lot of work. But once you get it done, though, it's a great feeling to know that you didn't make no error and it's right. Okay, any questions on that, sir? Pretty self-explanatory for the most part. All right, let's look at another one real quick. On this problem, I'm gonna have to find and complete the what we call the factorization of all 5 zeros of a polynomial. All right. In order for me to do that, it's gonna require some swift stuff, and I got about 5 minutes to do that. Maybe 6 minutes actually. Can I erase this?
Mm-hmm.
All right. Now, so I gotta complete the factorization of all 5 zeros of the polynomial. Alright, my polynomial is px equals 3x to the 5th, so 24x cubed, so 48x. Alright, Scott, what do we do first, sir? The first thing we do in this particular problem. Let me ask you this. What's the greatest common factor on the number side here?
Probably 24.
No, because we have a 3.
Oh.
It's probably just 3.
It's probably just 3.
So, what about the x's? What about the x? What's the greatest common factor there?
The x's? X.
Just x, right?
Just x.
So, guess what that means? I can pull out a 3x.
Mm-hmm.
Alright, so I pull out 3x. And what happens is I get 3x times x to the 4th plus 8x squared plus 16. Alright, now, but is there anything else I can do with that problem?
Foil. I mean, distribute.
I can distribute, but I'm looking for the complete factorization. So whatever's in parentheses, I need to try and see if I can factor that guy. Right? I need to know. So I need to see if I can factor it. So, oops, didn't mean to do that. Okay. We need to see if I can factor it. So, it's a perfect square of some sort. X to the 4th and 16. What's the square root of 16?
4.
What's the square root of x to the 4th?
Square root of x to the 4th. 4.
X squared.
X squared.
Right? Yeah. So, this really is 3x times x squared plus 4 squared, isn't it? Twice. Alright. Any question on that so far? You good, sir? Alright. Now what I do is I want to solve for x already. So 3x equals 0, x squared plus 4 equals 0. Right? If I divide by 3 on both sides, x equals 0 here, right? If I subtract 4 here, x squared equals negative 4 is an imaginary number. You can't have a square root in a negative. I mean, you can,
but
it's complex and it's imaginary. Not senile or crazy, but it's imaginary. It's there. So I do the square root of 4, which is what?
X squared, or 2.
2, right? Yeah. And the next thing is I, because it's imaginary, right? So this really turns into a breakdown, if you will, of x squared equals, or x equals the square root of negative 4, and the square root of actually 4 times negative 1. Square root of 4 is 2, it gets pulled out. It's positive or negative 2i and 0. So, what's cool about this situation is 0 is one of my answers, positive or negative 2i is one of my answers. That's 3 answers, right? 3 answers. But, what does this say here?
Squared. Or
Ah.
to second power.
Squared, right?
Squared.
So guess what? And that answer is what?
2 times.
2 times. Twice. I now have my 5 zeros and 1 problem, and I'm golden. Okay? Key things to know real quick, or key points to know. There are some good ones to know, and you may want to write these down. You and also everybody else out there in the world. I got about a minute to show you. Do you have all this down, sir?
Not yet.
Alright, we'll go ahead and I'll give you a little bit of time to write this down. If time doesn't run out, you can write down other ones, or we'll do it after the video when it's here. As y'all can see out there, the problems are working out pretty nicely. Well written out and described. But again, if y'all have any questions about anything I do, please comment on my videos on Facebook under It's Not Complicated Tutoring or Veal. Or if y'all know me, give me a shout, text message me and ask me about the videos, maybe a problem that you don't understand that you want to know.
Alright, I'm done.
And I'll let you know. You done? Alright. Cool, I got about a minute to write this down. So I'm gonna erase this. If y'all need to write it down, I would suggest you put the video on pause and you write it down. Alright. Good ones to know. Key terms and good factorizations to know. One is going to be P of x equals x cubed plus x. This factors into x times x minus I, x plus I. Secondarily, P of x equals x to the 4th plus 18x squared plus 81 turns into x minus 3i squared, x plus 3i squared. And then thirdly, P of x equals x to the 5th minus 2x to the 4th plus x cubed. That one is going to be x cubed times x minus 1 squared. Those are the key factorizations that you need to know. Alright? Make sense? And we're done. Once again, y'all, thank you for tuning in. I'll be doing more videos, obviously, as we get through it. Tons of more videos. So, this is CEO signing out. Holla.